Greetings. I'm Wes Gollum, the New Hampshire Energy Geek, and welcome to our fifth in a series of videos about exponential growth, COVID-19, our economy, and the environment. In the past four videos, we've seen that the growth pattern of COVID-19 is that of an exponential J-shaped curve, and it's actually one of the two patterns that are found in nature when we look at growth. We've seen that populations that grow exponentially with that J-shaped curve shoot way past their carrying capacity until a limiting factor like disease causes the population to crash. Human populations grew arithmetically until about 1750, at which time, around the time of the Industrial Revolution's beginnings, the exponential growth began to occur. We, of course, cannot know the exact carrying capacity of the Earth. From an ecological perspective, COVID-19 and the Spanish flu a century ago are limiting factors which serve to limit our population. The Spanish flu killed about a third of the human population on the planet at the time, and we've yet to see what COVID will do. We've seen that exponential growth of human population has put exponentially growing demand on the resources we depend upon, and we've discussed the resulting dwindling of many of those resources which we need to keep making the goods and services we use every day. Today, I'd like to explore the effect of this growth on our environment and on the continued habitability of our planet. This now familiar graph shows the connection between human population and increased fossil fuel consumption. In their book, The Trajectory of the Anthropomorphicene, The Great Acceleration, the authors look at both socioeconomic trends and what they call Earth system trends. And lo and behold, when they measure the changes, they almost always find an exponential growth curve. With each added person on the planet comes a demand for more material goods and services. Exponential increases in the burning of fossil fuels have led to exponential increases in the resulting pollution. Similarly, with other forms of pollution resulting from the increased use of our material resources by humans. There are currently over 7.3 billion people on the planet, about triple the number that there were when I was born in 1951. All of those people need food, water, shelter, and all the other things we call necessities. How many of those people can the Earth support? What is the carrying capacity of the planet? We don't know exactly. Some studies indicate we have grown past the carrying capacities. Others suggest we're fast approaching the limit. The pressure of so many people demanding the resources needed to live is putting significant stress on the natural systems of our planet. The more stress, the more likely humans are to run into a limiting factor such as our current pandemic. Take our need for food. Agriculture is responsible for about 80% of the world's deforestation. The intensive farming methods which have been adopted by agribusiness to provide for the food needed for an exponentially growing population uses lots of pesticides and fertilizers, both made from fossil fuels. This has increased our harvests dramatically in the past 100 years, but there are signs that we're reaching the limits to our yield. And as we mentioned in a previous video, the pressure of human expansion encroaching deeper into previously unsettled land has increased our contact with wild animals which carry viruses potentially harmful to humans. Thank you. Since we are using chemicals which are not found in nature and have no means for decomposing, agricultural runoff, the wastes of agriculture, cause depletion of oxygen in ponds and rivers and destroys marine life when it gets into the ocean. This oxygen depletion is called eutrophication, and currently there are over 100,000 square miles of dead zones in the world's ocean today caused by eutrophication. The costs to mitigate this would run into the billions of dollars. As the world's population increases, there is a growing demand for wood, paper products, and for the land to grow food and build houses. All this leads to deforestation. The Amazon rainforest, which is being deforested at a horrifyingly quick pace, is responsible for 20% of the world's oxygen supply. Our supply of fresh water is also being stressed. In 2016, 15% of the world's population lived in places where the demand for water was higher than the supply. That percentage is expected to rise to nearly 50% in the next 10 years. Another report suggests that as much as 2/3 of the world's population will have water shortages within the next 5 years. Activities like waste disposal from residential, commercial, and industrial areas, oil spills, and runoff from agricultural all contaminate bodies of water when it rains and runs off. Another environmental issue impacting water systems is overfishing, which causes a reduction in the diversity of marine life and the depletion of our food stocks. One of the biggest environmental impacts of human activities is air quality. The transportation sector contributes heavily to air pollution because most of the transportation, including cars, planes, and ocean vessels, all use fossil fuels. And when burned, as we know, fossil fuels release carbon dioxide and other greenhouse gases into the environment. In addition, the manufacturing industry grows exponentially with the expansion of human population. Like most other human endeavors, manufacturing is an energy-intensive process, as are many of our other activities. Some of these pollutions deplete the ozone layer and expose the Earth to dangerous radiation from the sun. Notice this graph has leveled off, and that's due to human intervention, a treaty which is being followed to limit the use of ozone-depleting chemicals. Human activities in the environment interfere with the planet's natural balance, making the Earth's climate less stable and predictable. Carbon dioxide, methane, and nitrous oxide are all what have come to be called climate change gases. That is, gases that act like a greenhouse and warm the planet. Climate change brings unprecedented heat and flooding, increased numbers of hurricanes and typhoons, fiercer brush fires, and drought. All these are clues that the environment cannot take much more negative human impact. There were 4 times as many people on the planet in the year 2000 as there were in the year 1900. In that same time period, CO2 emissions increased 12-fold. How much more can the planet take? We don't know. What will the limiting factor be that will cause the exponentially growing human population to do what all exponentially growing populations in nature do? Crash. We don't know that either, but we sure have some hints as to some of the possibilities. What can we do? In a general way, all of the environmental issues we face come from the fact that we are trying to dominate nature, and it is not working. Another way to approach the problem would be to recognize that there are natural laws that we must follow, meaning if we don't control human population and its resultant negative effects, nature will. Natural systems have co-evolved over the millennia to use energy that flows from the sun and cycle matter that exists on the earth. These systems never run out or run down because they are self-sustaining. Humans could adapt our behavior to be in line with these self-sustaining systems, which sustain all of the life on our planet. There is no waste in these systems. Whatever is made by nature is broken down, like a great Lego set, today making trees, tomorrow breaking down to the original component parts, and then being remade as skyscrapers or cows. The same atoms, like those Legos, just put together differently. In the book Cradle to Cradle, the authors suggest that the manufacturer of any material good be responsible for its safe breakdown into its original component parts so the matter can be reused and not left to cause the kind of pollution issues we've seen here growing exponentially. It is clear that burning fossil fuels is not sustainable. There is a limited supply, and the side effects are devastating to our environment and to the planet. It is also clear that we have the technology to convert to sustainable energy sources. As suggested in the first video, the laws of nature are inviolate. They are not human-made and cannot be changed or ignored by humans. Our economy, however, is a human construct, and it is at odds with the laws of nature. If we persist in the battle, we will lose. We cannot have a sustainable system that requires unlimited exponential growth. Therefore, we must find a way to convert to an economy which is a steady state, meaning it is not dependent upon growth to be healthy. These are by no means easy or cheap fixes. They will take all the human ingenuity and effort that we can muster. Hopefully, we're up for the task. I hope you will join me and watch future videos which will explore some of the practical ways we might move towards implementing these ideas. I'm the New Hampshire Energy Geek, and I thank you for watching. If you found this video series interesting, I would appreciate it if you would do the like thing on my Facebook page and also on the New Hampshire Energy Geek YouTube channel. Thanks again for watching. Stay safe. And if I don't see you in the future, I'll see you in the pasture.